Hi everyone, this is Dr. N. Pothanna, Associate Professor of Mathematics, VIGNANA JYOTHI Institute of Engineering and Technology, Hyderabad. In the last class, I have explained about what is an exact differential equation and how to find its solution. This class, I am going to explain about what is the non-exact differential equation and how to find its solution. Just 1 minute, I want to recap that previous class. Exact differential equation means, suppose the differential equation, the first order and first degree differential equation, which is given in the form mdx plus ndy equal to 0. To say that this is an exact differential equation, so we have to find derivative of m with respect to y partially and derivative of n with respect to x partially. If both these derivatives are equal, then we can say that the given differential equation is exact. If both these expressions are equal or derivatives are equal, then we can say that the given differential equation is exact. Now, coming to the non-exact differential equation, so to say that the given differential equation is non-exact, after finding dou my dou y and dou n by dou x, we have to verify that whether these two derivatives are equal or not. If these two derivatives are not equal, that is, if dou my dou y not equal to dou n by dou x, then we can say that the given differential equation is non-exact. Then, if the differential equation is non-exact, then how to find its solution? If the differential equation is non-exact, then the role of integrating factor will come here. There are many ways to find out the integrating factors here. Okay, so this class I am going to explain about how to find the integrating factor by using method 1 and how to find the integrating factor by using method 2. So actually the use of integrating factor is after multiplying the integrating factor to the given non-exact differential equation, the differential equation, the non-exact differential equation becomes exact. So once it is exact differential equation, we know that in the previous class I have explained about once the differential equation is exact, then the general solution of the exact differential equation, you can write it as the general solution of the exact differential equation, we can write it as integration mdx plus integration ndy is equal to c. So here in the first integral we have to keep y as constant, and in the second integral we have to take terms, the terms do not contain x, the terms do not contain x. In the second integral we have to take only the terms which are not containing x. So last class I have given this formula to find out the solution of the given exact differential equation. The problem comes here whenever the differential equation is non-exact. Just now I am saying that, so if the differential equation is non-exact, then there are various methods are there to find out the integrating factors. So now I will discuss how to find the integrating factors by using method 1 and method 2. So in method 1, what we'll see is, in method 1 is, so whenever the differential equation, the first order differential equation mdx plus ndy is equal to 0, whenever the differential equation mdx plus ndy is equal to 0 is non-exact, and it is homogeneous, the differential equation is homogeneous, then the integrating factor if will write in this case as 1 by mx plus ny, provided mx plus ny not equal to 0, If the differential equation mdx plus ndy equal to 0 is non-exact, that is this dou my dou y not equal to dou n by dou x, and we have to see that, we have to also verify that whether the differential equation mdx plus ndy equal to 0 is homogeneous or not. If it is non-exact and homogeneous, then only we'll take the integrating factor as 1 by mx plus ny. So where the denominator mx plus ny not equal to 0. So by taking one example, I will clearly explain about how to find the solution of the non-exact differential equation. By taking one problem, I will explain about how to find the solution of the non-exact differential equation. Coming to one example, solve the differential equation. Solve the differential equation x square y into dx minus x cube plus y cube into dy is equal to 0. So this is the first order first degree differential equation is given. We want to find out the solution of this differential equation. Whatever it may be the differential equation, we have to see that whether it is exact or not first. If it is exact, in the last class we have discussed about how to find its solution. The problem comes whenever the differential equation is non-exact. So whenever the differential equation is non-exact, then we need to calculate the integrating factors. Okay, in method 1, so we can say that if the differential equation is non-exact and if the differential equation is homogeneous, then we'll consider the integrating factor as 1 by mx plus ny. Okay, so let us verify whether it is exact or not. So here this differential equation in the form mdx plus ndy is equal to 0, where m is equal to x square y, m is equal to x square y, and n is equal to mdx plus ndy, no? So n must be here minus of x cube plus y cube, or you can also write this as minus x cube minus y cube. Now we have to differentiate m partially with respect to y. So we'll get this as, with respect to y now we have to keep other terms as constant, x terms as constant, and x square into, so differentiation of this y with respect to y is 1. So therefore this becomes x square. Then coming to the derivative of n with respect to x, differentiation of n partially with respect to x. So y term is constant here, the differentiation becomes 0. So differentiation of x cube is 3x square. So we can write this is minus 3x square minus 0. So this is equal to minus 3 square. Okay, so here we got dou m by dou y is equal to x square and dou n by dou x equal to minus 3x square. So both are not equal. Dou m by dou y not equal to dou n by dou x. Therefore, we can say that the given differential equation is non-exact. So once the differential equation is non-exact, again we have to come back to the given differential equation. So we have to verify whether the differential equation is homogeneous or not. If it is non-exact, then only we have to see whether it is homogeneous or non-homogeneous or whatever it may be. So now, so homogeneous means we have to see that, so in each and every term, so if you see the first term, x square y is there, no? So the degree of x square y is, so that is x square y term. So to verify that whether it is homogeneous or not, so the degree here is x square into y power n. So that is, so 2 plus 1 you have to take. So that is the degree of this is 3 we have to take. So x square y power n, the degree is here equal to 3. The degree of this is 3. And each and every term is having the same degree. So we can say that it is a homogeneous. And likewise, x cube also, the degree is 3 here. So this 2 plus 1 we have to take. So here, so power of this x is 3, therefore, so the degree of this term also 3, then degree of this y cube also, it is 3. So the degree of x square y is 3, the degree of x cube also 3, the degree of this y cube also 3. Any differential equation in each and every degree, in each and every term is of same degree, you can say that it is homogeneous differential equation. Now the given differential equation is non-exact and it is homogeneous, then we can take the integrating factor as 1 by mx plus ny. Before calculating 1 by mx plus ny, let us calculate mx plus ny here. So m into m here is x square y. Okay, so into x is there plus n into, so n into y, already y is there, then minus of it is x cube plus, first I have written y here, okay, n into y now, so minus of x cube plus y cube. Let us calculate this. This is x cube into y, then minus of x cube into y, then minus y power 4 it is. So x cube y gets cancelled, plus x cube y minus x cube y gets cancelled, minus y to the power of 4. So this is not equal to 0, right? So therefore integrating factor we can write it as 1 by, so it is minus y to the power of 4. So this is equal to minus 1 by y to the power of 4. So after finding the integrating factor, so we have to multiply this integrating factor with the given differential equation. Here our given differential equation is x square y into dx. Multiply this with the integrating factor, this becomes, so minus 1 by y to the power of 4, then minus of minus plus, already in the numerator we are having x cube plus y cube divided by it is y to the power of 4, since it is a multiplication. Now dy is equal to 0. So in the starting itself I told you that, so the use of integrating factor is to make the given non-exact differential equation becomes exact. Whether if you verify it or not, the definition itself is saying that to multiply the given differential equation with the integrating factor, the differential equation definitely that becomes exact. So now this is in the form some m1 dx plus n1 dy equal to 0. So let us simplify it further. So you can cancel out the like terms here. So this becomes minus x square by it is y cube into dx, then plus separate this. So x cube by y to the power of 4 plus y cube by y to the power of 4, it is 1 by y into dy is equal to 0. So this is in the form m1 dx plus n1 dy is equal to 0. So where m1 is equal to minus x square by y cube and n1 is equal to x cube by y to the power of 4 plus 1 by y. So actually no need to verify this. I am saying that after multiplying the given differential equation with integrating factor, that becomes exact. So exact means you know the condition of exactness. So that means definitely we'll get here as dou m1 dou y is equal to dou n1 by dou x will get. So if you assign this as equation 1, so therefore you can say that equation 1 is exact now. Equation 1 is exact. So if the given differential equation is exact, we know that how to find the solution of the given differential equation by taking that formula. So what we have to do here is, so the general solution formula will write here as the general solution is, here is, okay, so our m becomes m1, that is m1 dx plus n1 dy is equal to c. So anyway here we'll treat y as constant. In the second integral we take the terms free from x or the terms do not contain x. Okay, so now that implies integration m1 dx. What is our m1? Minus x square by it is y cube into dx, then plus here we have to take the terms which are free from x. Okay, so in n1 if you see that this term is containing x, don't take this term. So because which is containing x, in the formula we are saying that, so in the second integral we have to take only the terms which are free from x. Okay, so this first term is containing x, we don't want to take this term. Then so this 1 by y term is not involving any x, so now you can consider this term here, that is only 1 by y, that is 1 by y into dy equal to c here. Okay, so here in the first integral I'm saying that we have to keep this y as constant, that is minus 1 by y cube as constant. Integration of x square is x cube by 3, then plus integration of 1 by y is log y is equal to c. Further also you can simplify this. This becomes minus x cube 3y cube plus log y. Log y is equal to c. So this is the required solution of the given non-exact differential equation. Okay, so this is about the using the method 1, how to find out the solution of the non-exact differential equation. Now I will give you one homework problem. This you can try it later. Okay, so the problem here is solve the differential equation y square dx plus x square minus xy minus y square into dy is equal to 0. If you want, you can note down the answer also. Here the solution we'll get for this problem is x minus y into y square is equal to some c square into x plus y, c square into some x plus y, right? So this problem you can try at home. So this is about the method 1 to find out the solution of the given non-exact differential equation. Now coming to the method 2 to find out the solution of the non-exact differential equation. So in method 2, what we'll see is, in method 2, so suppose the differential equation mdx plus ndy is equal to 0 is non-exact, If it is homogeneous, we are saying that it is method 1. Okay, if it is non-homogeneous, that means each and every term in the given non-exact differential equation is not same. You can say that that is non-homogeneous. If it is other than homogeneous and if it is non-exact, and we have to see that this differential equation is in other standard form or not. So if the differential equation mdx plus ndy equal to 0 is non-exact and it is in the form this differential equation only mdx plus ndy, it is in the form some y into fxy. It must be function of xy. It is not function of x comma y. That you have to observe here. Y into f of xy plus x into g of xy dy is equal to 0. If the differential equation is non-exact and it is non-homogeneous, and if it is in the form, this differential equation is in the form, this standard form, y into fxy, function of xy dx plus x into g of xy into dy equal to 0. If it is this form, then the integrating factor will write here as 1 by mx minus ny, where mx minus ny not equal to 0. Okay, if mx minus ny not equal to 0, then the integrating factor for this form will write as 1 by mx minus ny. Now I will explain, if the first order differential equation is non-exact and it is in the standard form y into f of xy dx plus x into g of xy dy equal to 0, then how to find out the solution of this non-exact differential equation. Now we will discuss. Okay, by taking one example, I will explain this now. So solve the differential equation. Y into 1 plus xy into dx plus x into 1 minus of xy into dy is equal to 0. So in the exam also, simply like that they will give the solve the differential equation. Sometimes they may not give in this direct standard form also. They may give in the last class also, I have explained them. They may give like dy by dx plus some numerator expression and denominator expression, like that also they will give. Okay, we try to convert that in the form. Last class also I explained them. So that in the form this mdx plus ndy equal to 0. Directly don't find the integrating factor for this standard form. So don't think that this is in the form y into some function of xy, then x into j of xy, then the integrating factor. Directly don't write. Sometimes, so this type of standard forms also, sometimes we may get it as exact. If it is exact, no need to find out the integrating factor. Okay, if it is exact, then we can find out the solution by taking directly mdx plus ndy is equal to c. That is the required general solution, right? Okay, whenever it is non-exact only, you have to go through the one by one all the methods. Method 1, then method 2, method 3. There are 4 to 5 methods are there. So one by one we have to see. Okay, so this is the first order differential equation. And what we have to see here is, so whether this differential equation is there in the form mdx plus ndy equal to 0 or not. Okay, so yes, directly it is given. So that given differential equation is there in the form of mdx plus ndy equal to 0. Then m is equal to here. So you can multiply this y with 1 plus xy. So this becomes y plus xy square, and n equal to multiply this x minus this becomes x square y. Okay, so m and n we have written here. So let us calculate this dou y differentiation of m partially with respect to y. So that is 1 plus. So anyway, x is constant, no? X is constant with respect to y. Differentiation of that y square is what? It is 2y. So this becomes 1 plus 2xy. Then differentiate n partially with respect to x. So we'll get this as dou n by dou x. We'll get dou n by dou x as, so 1 minus, here we'll treat y as constant. Differentiation of this y is constant, differentiation of x square is 2x. So now this is equal to 1 minus 2xy. Right? So here dou m by dou x we got here as 1 plus 2xy. Dou n by dou x we got here as 1 minus 2xy. So these two are not equal. So therefore dou m by dou y not equal to dou n by dou x. So it is non-exact differential equation now. So the differential equation is non-exact. So if the differential equation is non-exact, 1 minute we have to think. So whether this given differential equation comes under method 1 or method 2. Okay, so they will give one differential equation. So first of all we have to verify whether it is exact or not. Before that, actually we have to verify that, so whether that is in there in the form of mdx plus ndy equal 0 or not. Otherwise we need to convert that in the form mdx plus ndy equal 0. So we have to mention m and n, and we have to differentiate m and n partially with respect to y and x respectively. Then if both are equal, then using that formula, standard formula, general solution formula, we can find out the solution, whatever it may be the form. Okay, whether it is homogeneous or whether it is the standard form, whatever it may be, directly you can write the solution. Okay, so whenever the differential equation is non-exact, again we have to stop it for 1 minute. We go back to the given differential equation. We have to see that whether this is homogeneous or not. So it is not homogeneous because the degree of y is 1 here. The degree of xy square is, so it is 1 plus 2, that is 3. Okay, not equal here also. So here also in n also degree of this x is, this term is 1. The degree of x square y is, so that is 3. So 2 plus 1, that is 3. So therefore it is non-homogeneous. Then immediately we have to think that, so it is non-homogeneous, then we have to go for the method 2. So method 2 is saying that, so whenever the non-exact differential equation in the form y into function of xy dx plus x into function of xy dy equal to 0 or not. Yes. So this is in the form some y into this is function of xy. So you may ask that, so 1 place is there? No sir. Okay, 1 plus 1 is not function of xy now. So actually you can write this as, so this as xy to the power of 0, no? 0 you can write. So therefore this is function of xy only, this term also. So xy to the power of 1 it is, xy is there. And here also 1 you can write xy to the power of some 0. That becomes 1 only. So completely, so this 1 plus xy is, so this in the form f of xy. And this is in the form some g of xy. So therefore the above differential equation in the form y into function of xy dx plus x into some other function, so function of g of xy dy is equal to 0. So therefore in this case, so we'll write the integrating factor as 1 by mx minus ny. So before finding that, we need to calculate mx minus ny. So what is m here? So m here is y plus xy square into x minus n here as x minus x square y into y. So if you simplify this, so this is equal to xy plus x square y square minus xy plus x square y square. So plus xy minus xy gets cancelled. So it is 2x square y square not equal to 0. So therefore we'll write the integrating factor as 1 by 2x square y square, because it is 1 by mx minus ny. Now after finding the integrating factor, we have to multiply this integrating factor with the given differential equation. So now coming back to the given equation, that is y into 1 plus xy dx it is, then plus x into 1 minus xy dy is equal to 0. So multiplying this with the integrating factor, we'll get this as, that implies multiplying this differential equation with the integrating factor 1 by 2x square y square, we get y into 1 plus xy dx multiplication, no, this becomes into 1 by 2x square y square, then plus x into 1 minus xy divided by 2x square y square into dy is equal to 0. So that implies, we'll write this as, let us separate this. So this becomes 1 by 2x square y square plus xy square by, it is 2x square y square into dx plus it is x by 2x square y square minus x square y by 2x square y square into dy is equal to 0. So that implies, so here y gets cancelled, this becomes 1 by 2x square y we got first term, plus y square gets cancelled, x and x. So this becomes 1 by it is 2x into dx plus, so x gets cancelled, 1 by it is 2x y square minus x square also here also one time gets cancelled, 1 by it is 2y minus 1 by 2y into dy equal to 0. Let us consider this as equation 1. So this is in the form some m1 dx plus some n1 dy is equal to, it is 0. Okay, so m1 here is this one, this expression, and n1 is this. Okay, so if you find out this derivative of m1 with respect to y, definitely we'll get it as the derivative of n1 with respect to x. Definitely we'll get this, because after multiplying the given differential equation with integrating factor, whatever the required differential equation will get, no, definitely that becomes exact only. So therefore now equation 1 becomes exact. Equation 1 is exact now. Once it is exact, we can write the solution as, the general solution as, we know that the general solution as integration, it is m1 dx plus integration n1 dy is equal to c. Here y constant we need to take, and you know that the terms free from x we have to take here. Now coming to integration of m1, what is our m1 here? 1 by 2x square y plus 1 by 2x into dx plus, here I am saying that in the second integral we have to take the terms which are independent on x. This we don't want to take because it is involving x. This we want to take because it is not involving any x. So simply it is minus 1 by 2y dy, this is equal to the arbitrary constant c here. Okay, so that implies, so in the first integral we have to keep y terms as constant, that is 1 by 2y outside you can write. Now integration of 1 by x square, actually it is x power minus 2, you can write integration of x power minus 2 becomes minus 1 by x. then plus coming to integration of this 1 by 2 is a constant, integration of 1 by x dx is it is log x, then minus 1 by 2 is a constant, integration of 1 by y with respect to y is log y, so is equal to c. So that implies minus 1 by xy plus log of, so I want to take 1 by 2 outside here, I want to bring this 1 by 2 to that side, so log of this in the form log a minus log b, that is log of a by b. So this is equal to, bring this 2 to this side, so this RHS side, this becomes 2c, or otherwise you can write this as some c star also you can write here, c star also you can write. So since it is arbitrary constant, you can write this as simply c star or k, whatever it may be, c star, right? So this is the required solution of the given non-exact differential equation by using method 1. So here if you want you can note down one homework problem for this method also. So solve the differential equation, this is very important problem. Xy sine of xy plus, in place of theta it is xy. Okay, don't write sine of xy is some y into sine x, it should not be like that. Cos of xy, theta is xy here, both the terms, into y dx. Don't see that y into fxy initially. First of all we have to verify whether it is exact or not. If it is non-exact only, one by one you have to see all the methods, method 1, method 2, right? X into dy is equal to 0. This is a given differential equation. If you want you can note down the answer also. You get the answer for this is x into secant of xy divided by y is equal to c. This you can do at home. Okay, so this class I have explained about what is a non-exact differential equation. Then if it is a non-exact differential equation, how to find the integrating factors by using two methods. Method 1 is non-exact and homogeneous. Okay, then the integrating factor is 1 by mx plus ny will take, then we multiply integrating factor with the given differential equation. Then using the method of that exact differential equation, same way we'll find out the solution of that differential equation. Method 2 is what? If the differential equation is non-exact and it is in the standard form like y into function of xy and x into some other function of xy dy, that is equal to 0, then we'll take the integrating factor as 1 by mx minus 1y, mx minus ny. Then after finding that expression, we'll multiply that integrating factor with the given differential equation, then we can find out the solution. Okay, thank you all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.